In this video, we will learn Ktor RestAPI with MongoDB. And also, I will teach some basics about client API database relationship. So you could be beginner for server side or experienced programmer who want to learn Ktor with MongoDB. If you are experienced, you can pass directly to the coding part. Let's start. You might ask this question: can we really use Ktor in the backend? Because it's not as much as popular when we compare with the others. The short answer is yes, we can. Let me explain. I investigate about Ktor is production ready or not. So I research user comments on Reddit. This guy, whose nickname is Hariri, is in the official Kotlin team, and he says they are using Kotlin on their space project, which is helpful for CI/CD management. So it's a big project and it's already in production. I found that some of these companies uses Ktor in their backend fully. Some of them uses for just some microservices in their backend. According to Ktor.io official website, these people give many evidence that Ktor production ready. I divided this video into 5 parts. I will start with why we should use Ktor. Then we will look at what can Ktor do, client API database relationship, comparison, SQL and NO-SQL. Lastly, the coding part that we will code basic Ktor HTTP API. Let's start. Why we should use Ktor as server-side backend. If you are watching this video, you probably know the Kotlin programming language. By using Ktor, we benefit from many awesome features of the Kotlin language. For example, coroutines, lambda functions, extension functions, null safety, and plugin support. Moreover, it's easy to set up and use. In addition, according to Kotlin.io, Kotlin project is lightweight and flexible. With the power of Kotlin, we can create HTTP APIs, interactive websites, and WebSocket applications. In addition, we can use Ktor client instead of retrofit in Android. Now, let's examine the client API database relationship, which is very significant topic to understand the big picture. Client can be anything like mobile application, website, desktop app, etc. We can think API as a waiter because it's interface between client and database. Client can request any data from API. For example, client asks for all users list from API. In this situation, API will ask for all users from database. And when API obtain the data from database, API will give data to the client. API could be written with .NET, Django, Node.js, etc. It doesn't matter what the API was built with, because in the end, all of these technologies do the same job. Only the programming language changes. In this video, I will use Ktor as an API and I will use MongoDB as a database. Before moving on to the coding part, I would like to explain the difference between SQL and NoSQL, because MongoDB is a NoSQL database. SQL databases use tables like users, permissions, and user permissions. Moreover, all records have to follow specific schema. For example, in the users table, ID, name, and age must be there for all user records. You can't say that I will not put John's age. You can pass it as a null, but you cannot fully omit for specific user record. Lastly, SQL is relational. When we want to assign permissions to users, we should use relation with new table. For example, to specify John's permission, we should establish a relation as in the last table. John's user ID is 1 and the permission ID is 2. NoSQL databases use documents and collections. There is no table. There is a database named Sales App in the pink area. There is collection in blue area, which names are users and permissions, and these collections has documents. Moreover, there is no strict schema. For example, if we want, we can omit only Maeve's age. Lastly, it's not relational. As you can see on the purple users collection, there is two documents, John and Maeve. And in their JSON data, there is permission field. So it does not need any relation. Let's jump into the coding part. First of all, as an IDE, I will use Intellij IDEA Community Edition, which is free to use. We need Ktor plugin to develop a Ktor API. So open Intellij, tap to plugins. In Marketplace, search for Ktor and install Ktor plugin. After installation, we have to restart the IDE by clicking Restart button. Now, we need a project. We will not use Intellij for creating a project. There is an official Ktor website for creating a base project. Let's go to start.ktor.io website. You can find the link in the description. First, we need project name. I'm giving it a name. Then in settings part, I will choose Gradle Kotlin. In website section, enter a package name like furkan.com. In Ktor version, you can use 2.0.3. As an engine, we will use Netty. And in configuration part, we can choose Hackon file, which is easy to read. Then click Add Plugins button. In this section, we will add some plugins to the project. You can also install other plugins you want according to needs of your project. After creating the project, you can add plugins from your Gradle file. You don't have to add it here. We need 3 plugins in this project. First one is routing. And second one is content negotiation with JSON. Content negotiation and JSON. These 2 plugins is for JSON parsing, and when you finish plugin edition part, you can generate project with this button. It will download a zip file. You have to extract it from zip, then turn back to the Intellij and open our extracted folder. To open your extracted file, you can use this open button and you can choose your project folder. After building phase is done, we are ready to coding. Before we start coding, I want to show you the project folder and file structure. We have 4 main parts. Our initial project already have 2 parts. One is plugins package, which is hold our plugin settings. Other one is application class, which has our main function. We will create 2 new package, routes and data. Routes package, which is hold our endpoint behaviors. For example, what will happen if user request to the getEmployee endpoint. In this video, I will develop employee route and I will let you task route section as practice. Data package holds our collection models and request models like employee task, employee request, delete employee request. And there is company database class. We will create MongoDB query functions in this class. And we will use these functions in related routes in here. I will explain why we need simple response while we are coding. Let's get started. First, we need to add a few dependencies to be able to use MongoDB in the project. Let's go to the Gradle file and in dependencies section, let's add these dependencies. You can find these dependencies in the description. Let's click synchronize button. Okay, dependencies successfully added to the project. Now we will create our folder structure. Let's go to the source main Kotlin file. In order to see folder structure more clearly, let's deactivate compact middle packages from here. Let's create data package under furkan. And inside that package, we need model and requests package. And inside that package, we need model and requests packages. Also, we need roots package under furkan folder. Now, let's open the company database Kotlin file under data folder, where we will access our database and write the functions containing our MongoDB queries. I'm creating a client for MongoDB operations. Then I am creating a variable that holds the database. When the database is created, this will be our database name. Now I want to access employee collection, which is on MongoDB. To do that, I will create employee data class under model, because we need to specify what kind of data structure employee has. I'm converting this class to data class. Then I am adding here some employee fields. I did the ID string because in MongoDB, ID is holding with string data type. Also, I want to do this field unique, so I can use bson ID in here. Also, I am adding annotation to specify that this is a bson ID. Then let's turn back to the company database. Then I create a variable to access my collection where the employees are kept. Everything is ready. Now let's write our functions that contain MongoDB queries.
First function is getEmployee for ID.
We will use ID when making the request. That's why we add it as a parameter to the function. This function will fetch all the information of the employee in a specific ID. That's why I wanted to return an object of type employee. In the function block, I write the MongoDB query and return it. This query means find the employee with this ID from among all the employees. Now I open employee root inside the roots package. I am coding my first endpoint task. To do that, first of all, I will delete this class thing. I will create an extension function. My first endpoint is getEmployee. I will get some data from database. That's why I am opening getClosure. If you remember, this endpoint needed an ID. So the client will send an ID to our API. We need to be able to get this ID. So I open a data class named employee request under the request folder. Let's convert it to data class. I am giving ID as a field. Then going back to my endpoint codes. Now I will get the ID sent by the client. We already create the function containing our database query is ready, which is getEmployee for ID. I am running the function with the ID from the client. We made our database query. Now we will report the results to the client with respond. Now, if there is an employee with such an ID, which means employee is not null, let's return the HTTP status OK and send the result. If there is no such an employee with this ID, we should inform the client that there is no such user. We just finished our first endpoint. There are two more. I'm going to code these endpoints a little bit faster. Let's return to the company database file. We will write a function that includes the query that adds a new employee to the database. In addition, if there is already an employee with such an ID, we will update the employee with the relevant ID instead of creating a new employee. I'm writing a function that takes the employee object as a parameter and returns a boolean. First, I create a variable that holds whether there is such a user. If such a user exists, I update the required user with the new employee information. If the user is new, I create an ID and save it to the database. By the way, was acknowledged returns true if query successful. I am going back to the employee root and creating my new endpoint with the post block as I am going to update or create. If an incorrect or missing parameter is sent by the client, I will return a bad request as HTTP status. If there is no problem with the parameters, I will send the result. If there is a conflict, I will send conflict HTTP status. We are done at our second endpoint. We are going to 3, which is the last endpoint. I'm creating a function that takes an ID as a parameter and returns a boolean. This function will be used to delete the employee with the corresponding ID. First, I find the user with the relevant ID. If there is an employee with this ID, that means if the employee is not null, I delete the user. I return to employee root and perform endpoint operations. We made all the endpoint of employee. Now is the time to test. We need the MongoDB Compass application and Postman to test it. First, we download MongoDB community server from MongoDB's website. I'm downloading for Windows. We are installing it with the complete edition. We are also taking this install MongoDB Compass as well. We go back to the IDE and run the main function in the application KT file. As you can see, the API is currently responding on this address. If you want, you can change it from resources application config in here. Now let's test it with Postman. Open a new request page with this plus button and then let's enter our URL. I'm going to look endpoint from code. Yes. I'll paste it in here. This endpoint needs some parameters. So to do that, click body, click row, then select JSON from here, then enter your parameters in JSON format. As you remember, our employee has these fields. you can let the ID empty because you are generating a unique ID in code. Let me show you. It's in here. Now we are ready, we can send the request. HTTP status returned not found because we forgot to call routes in API. I'm going to routing, which is in plugins, and I am adding here my routes. Let's restart the API. Then send the request again. It is successful and it's returned our message. Now let's check whether the worker is created with the help of MongoDB Compass. I'm clicking connect without changing anything. In here you can see our database. In employee, yes, it's created successfully. Now I will try get employee endpoint. In body, I will send the ID. We can take the ID from MongoDB Compass. Let's send the request. Yes, we successfully get the employee which has this ID. Lastly, I will try the delete endpoint. I am entering the URL. I am changing this with post. In body section, I will send the ID. Employee successfully deleted. Let's check it in MongoDB Compass. I'm clicking the refresh button and yes, it's deleted successfully. Finally, I create a simple response model so that the responses to all requests are in a single format. In the new model, there will be status, message, and data. Since the data will change according to demand, I give generic type. In employee route, I will change the responses with my new model. Let's restart the API. Then let's check our endpoints with the Postman. Let's create a new employee. It's created. Let's get that employee. Okay, this is successful too. And lastly, we will delete this employee. Yes. We have come to the end of the video. In this video, we learned the technical aspect and background of writing Ktor RestAPI with MongoDB. If you want to ask me a question, you can contact me from the contact information in the description. or from the comments of this video.